such as those markets over there. You can turn to avoid to build a basic Arduino robot using some basic components. This will include 2 continuous rotation servos, an HCSR04 ultrasonic sensor, an Arduino Nano. This is a Chinese clone, but for the purpose of this project you could probably use any Arduino, a power source, some male to male jumper leads, male to female jumper leads, some blue tack, obviously a breadboard, and some wheels for the continuous rotation servos. So to start with, we'll place the Arduino Nano on the breadboard. After doing this, I shall mount the ultrasonic sensor at the front of the breadboard using some glue tack. If you want to make this a more permanent project, you could use a glue gun or some more sort of permanent adhesive. Once that has been fixed to the front, you can then attach the continuous rotation servos to the bottom. These are just normal hobby servos which have been modified for continuous rotation. This is a fairly easy procedure to carry out, which I won't explain in this video, but I'll link a video below which will explain how to do this to your own servos. On the bottom of most breadboards there's a piece of sticky foam which is usually covered up by this. Now you could use this to attach the servos, so I'm going to peel off the front part of this foam which I've already cut, and I shall affix the servos to this. So the servo is attached to the bottom of the breadboard, like so. Just get that one aligned a bit better. There we go. Once you've done this, you can start connecting some of the wires. So I'm going to connect the ground of the servo, which is the brown cable, to the ground on the Arduino. This is a male to female connector, so I'll use a male to male connector. To the ground here. And I'll do this for the other servo as well. I like to use dark colours for the ground so it's easier to see what they are. Then connect the 5-volt cable, which is the central cable on most servos, to the 5-volt rail on the Arduino. Again, I like to use bright colours to indicate this so it's easier to see afterwards. You then need to connect the signal cable of the servos. I'm using pins 9 and pin 7 to do this. So the servos have now been connected. Can then connect the ultrasound sensor. This is using the female to male connectors. Connect the ground of the ultrasound sensor, which is indicated clearly on the front of it, to the ground rail of the Arduino. Then connect the VCC to either the 5 volt or the 3 volt. I tend to use the 5 volt because I find it works better, of the Arduino. You then need to connect the trig and the echo pins to the Arduino. Here I've defined the trig pin as pin number 11. And the echo pin as pin number 12. So now all the connections have been made to the servos and the ultrasound sensor. I find sometimes the servo cables can come a bit loose as they're not very well fitting, probably because they've been a bit overused, so I tend to use a blue tack to secure them in place. Now to try and get some of these cables out of the way, I'm going to use this elastic band here to try and tidy some of this up and make it look more neat. You don't need to do this for the ultrasonic sensor cables, as they should also already be rather compact, so mainly just for the servo cables, because obviously they're going to be double length. So if you just double them up like so, and then just put the elastic band around them. Then that just secures them in place and prevents them from getting in the way. Now, for this, you're going to need a power source. You could use a 4 AA battery power source, but as you can see, compared to the size of this simple robot, this is rather large. You could also attempt to use a 9 volt battery with a connector, but these provide very little current and won't be sufficient to power the servos and the ultrasonic sensor, as well as the Arduino. So I'd recommend using a lithium-ion phone battery. This is a phone battery I got from an old phone, and I've just soldered 2 cables to the positive and negative terminals on it. And I've also put a blob of solder on the middle terminal on the battery. This enables me to still charge it using the phone and elastic band, but this allows me to connect it to my Arduino. This supplies about 3.9 volts, which, although slightly too small for the Arduino, it seems to work perfectly. So this is the power source I choose to use. So if you just connect the ground to the ground on the Arduino, and I'll be using the ground on this side of the Arduino for this. And then the 5 volts to the 5 volts on the Arduino. I'll just point out that it'd be useful to use a switch in this case. So instead of connecting the ground straight to ground, I'm going to connect the ground to rail 14 on the breadboard and connect the 5 volts to the 5 volts. This means that then I can use a male-to-male connector from 14 to ground in order to switch the circuit on and off. And I can just connect that to 15 when I don't want it to run. It's usually a good idea to blue tack the battery down in case it moves while the robot is operating. I'm just going to use blue tack for this, but obviously you could use elastic bands or a glue gun to do this. Finally, I'm going to add the wheels. These are just servo brackets with pieces of circular cardboard glued to them, and this should work fine as wheels. So I'm just going to put those on, and you have your finished robot, which has an ultrasonic sensor and 2 continuous rotation servos. A real obstacle, such as those baskets over there, you can turn to avoid. So as you can see, it's a very simple robot, but